Good afternoon, everyone. My name is Richard Kobe, and I'll be moderating today's session. Um, I am a board member of the Michigan Forest Biomaterials Institute. I'm also the chair of the Department of Forestry at Michigan State, and I'm pleased to be moderating today's session on hardwoods for mass timber, opportunities and challenges in the U.S. Before getting to today's webinar, I just wanted to go through some logistics. If you could advance the slide. So first, please be sure to mute your voice as part of the webinar. Turn off your webcam. And when we get to the question period at the end, you can submit questions via the chat. And there also would be the option to raise your hand, and I will moderate questions for today's speaker. Next slide. But first, I just wanted to say a little bit about the Michigan Forest Biomaterials Institute. The Institute is a group of industry, government, and academic institutions that are cooperating to enhance the quality of life in Michigan through the use of sustainable forestry and supporting communities and the economic livelihoods of communities through the innovative and responsible production, use, and recycling of forest biomaterials. And if you want to learn more about MIFB, please go to our website, and we will be offering more of these webinars going forward. So getting to today's speaker, I'm very pleased to introduce Dr. Shin-Fon Shea, who is an assistant professor of biomaterials at Michigan Tech University. He does a wide range of work related to wood, including different materials that could be derived from wood, lignin, and cellulose. He is also interested in thermochemical conversion of wood and fractionation, as well as wood protection and preservation, and has some really interesting research going on related to the incorporation of hardwood species into mass timber. So without further ado, I'd like to hand things over here to Shin-Fon. Thank you for giving the webinar today.
Thank you, Richard, for the nice introduction. Good afternoon, everyone. I'm Shin-Fon Shea. Today, I'm going to talk a little bit, share some information with you about the research that we conducted at Michigan Tech. So when I accept this invitation, the title, Hardwoods for Mass Timber Opportunities and Challenges in the U.S., it's a pretty big problem to talk, figure out, if I share, what we, why we do what we have done and how we did it and what's the results at Tech. And hopefully, through this can give you some idea about, the opportunities and challenges in the United States when we talk about using hardwoods for the mass timber. And so the mass timber products, you probably know that it's not a very new concept because we have some products before, like a glulam, structure composite number. These are all considered mass timber products. What's new is this cross-laminate timber, which is cross-laminate of lumbers and make massive panels, right? And the application of this type is more diversified than other types because you can use CLT in flooring, roofing, walls, all these things. But traditional glulam structure composite number usually they can be used as a post or beam, limited application there. So we are interested in this new mass timber CLT. That's what we studied here at Tech. So here, first slide, I just show a picture of the 3-layer mass timber, cross-laminated timber made of sugar maple that we made here in our lab at Tech, in Houghton, Michigan. And just to demonstrate, we can make these things, and very well engineered, very beautifully made, good product. And before I get to the details about the presentation, I want to, acknowledge, the support from AJD Forest Products, Hexion, and the U.S. Forest Service, for their support to the studies. So, two of the things I want to emphasize on today is include the characteristics of hardwood number, and what the technical challenges associated with the characteristic of hardwood number, and then the research or studies we've done on campus here. So the big question here is, we probably everybody has, is like why we even consider using hardwoods for CLT. Right? One of the major reasons I think is that CLT is a value-added product, and then we have the hardwood as a resources in the United States. So it's a natural thing to make CLT out of hardwoods. But the CLT is an opportunity, for hardwoods as a value-added product. To turn that opportunity into the reality, there are some challenges, barriers we do need to overcome. Okay. And this is especially important for lake states, where we are sitting in a massive amount of hardwood resources. So one thing, I've been thinking of a lot is that we talk about to make hardwood CLT and to produce hardwood CLT. So these are very two different aspects of the thing. Making hardwood CLT is considered to be the first step. Can we make it or not? And then we talk about produce, like hardwood CLT as a product. That will relate to more extensive aspects. You have to consider logistics, resource logistics, manufacturing, market, all that kind of thing. But for our study, we are at the making hardwood CLT stage, and so that's the first step. So, and the challenges are mostly is related to the material itself. So it's important to take a look at the major characteristics of hardwoods when we compare it to softwoods. So to get a better understanding about the challenges we are facing at the technical level. And so our previous studies focused pretty much on the on addressing those of technical challenges, so on making CLT. So there are a lot way more challenges in producing hardwood CLT. So, and that is the area we are getting into there. Okay. So we probably know that CLT was invented in Europe, and they started with softwood species, and when they look at their forest inventory for next 1500 years, they found that hardwood species gonna dominate their forest. I've never been in Europe, but this is from my readings. One of the species they looked at is European beech. Okay, and so they started to study European beech for CLT production. They're a good example. For research, it's like the research should be based on what we have, the resources. Okay, and now you look at the what species we have studied in the United States. only two, yellow poplar and hybrid poplar. Okay, and we know that we have more species in the forest in the United States. Okay, now the study very limited. Okay, if you look at our neighbor country Canada, they studied a little bit more species than us, right? They studied maple, poplar, beech, and birch. Okay, so in that sense, there are more opportunities, in the United States in terms of hardwood species for CLT production. So and even for the two species we started in the United States, yellow poplar and hybrid, they are not actually best for CLT production. For example, yellow poplar had a lower MOE compared to softwood species. Okay, and yellow poplar had some issues with the bonding performance, which we're going to talk about today. Okay, especially with the lower wood failure rate. Okay, and that's something we actually kind of confirmed in our study as well in terms of the anatomic features of hardwood species for CLT applications. So so all commercial CLT for building applications are made of softwoods, until to today. Okay, so it is good to look at the major characteristics of hardwood when we compare those to the softwood, and that will give us a better understanding, where the opportunities and the challenges are for using hardwood. Okay, so one thing is the first thing is the density, the specific gravity of hardwood, because usually they have a higher density. So what that means, right? Higher density usually means higher mechanical properties. So it's a stronger material, and it has better acoustic insulation properties, and a better, resistance to vibration. And these are all good things about higher density, but there are some issues, right, associated with higher density. The first one is the shrinkage, the movement of the wood. It's way much more than that of softwood species. And also the transportation, it's heavier, it's denser, the cost can be higher. Just name one or two. Okay, and the second one is the anatomic features and the wood chemistry. Right, this for softwood species, there are only basically like two types of cells, in the wood. It's relatively uniform, not much variation in the anatomic features of wood, but hardwood species, totally different story. We have 5, 6 major types of cells in the wood, more variation in the material. Okay, and the chemistry as well. This will affect, the reactions, the chemistry of the adhesive we're gonna use for, to bond them together, this kind of thing. And another aspect is the number, hardwood number, is not sawn or graded for structure applications, right? CLT is a structure composite material. And then right now the industry doesn't, grade the hardwood number for structure applications. Potentially there's a problem. How you gonna relate, what, visually graded, graded for appearance applications to structure applications? There's the obvious gap there. Another aspect is the moisture content. Hardwood numbers usually dried to moisture content below 8%, sometimes even 6%, just for the application. But for CLT production, the current standard for softwood species, the PRG 320, they require moisture content about 12%, plus minus 3%. So it's 9 to 15%. That means, when we use wood, a hardwood for CLT, we may not need to dry the wood to a lower moisture content. Okay. And so drying, we know that drying hardwood actually is more difficult than drying softwood. It's just the way it is, the nature of the material. But one thing um, that benefits, that is good about drying hardwood species compared to drying softwood species is the volatile organic compounds. We have way much lower volatile organic compounds coming off drying hardwood species. So its environmental impact is much lower in terms of drying hardwood species compared to drying softwood species. But longer drying time definitely increase the cost. Um, the other aspect I want to mention is the resistance to biological degradation. Okay, that's a aspect usually we don't put enough emphasis onto it. The material, resistance to decay and insects, and these are the problems we are facing every day, especially when you use wood in the southern regions. Generally speaking, hardwood species are less resistant to decay and insects like termites attack. We do have some very durable species, but they don't make the majority of the number of products. White oak is one, but it only has 16-17% in the timber land stock. The other important aspect is the species, the diversity of species. Many hardwood species in the forest. It's not like softwood species, can come from plantations, single species. These are the things, we have to be considering, when we talk about using hardwood species in CLT production. Okay, so all these characteristics of hardwood lead to some, technical challenges. I already mentioned some of them. So just to list some of them here, we think it's very important. Before we can actually produce CLT, hardwood CLT, we need to address, these problems. One is the bonding issues. So this is related to the higher density, the chemistry and anatomic features of hardwood species. We know that bonding hardwood species can cause some issues just from like previous study, but we haven't actually thoroughly studied this, especially when you combine numbers, not small pieces or veneers together. It's totally different. Okay. The other thing is the how we gonna relate the chemical with mechanical properties to the grids, since hardwood numbers are graded visually, right, for appearance applications primarily. Okay. And the other one is the strength properties, modeling them. This is related to the variation of the materials. More types of cells in the wood, more variations in the properties of the wood, that kind of thing. At attack, so we basically, kind of talked our study, on these challenges. The one thing we are focused on is the multiple species, considering, what do we have in the forest, the composition of the forest we have. And we believe, the multiple species is the way, now single species can actually supply enough wood for production of hardwood CLT. Okay, so with that, specifically studied, the effect of wood species on the bonding performance when we cross-laminate hardwood number. And the other one is that we evaluate and modeling some panels. So we made some panels and break them and see, where their mechanical properties are, compared to the other types of CLT made of other species. So for the study on the effect of wood species, so we choose the 7 hardwood species. They're all from lumberyard, commercially available. This hardwood number, and we also include 2 softwood species, which is very common in this region. And so we have 9 species. So and the question we ask is like, if we, can we make good hardwood CLT panels when we use in the existing manufacturing conditions, designed for softwood CLT? That's include adhesives, the adhesive application rate, pressing parameters to the time, temperature, that kind of thing. So these are all, factors we fixed, right? In order to study, the effect of the wood species. So all these parameters you see here, they are actually designed for a softwood species. Okay, so this is I want to put this slide here is because this is a new publication this year, right? Talking about the composition of the hardwood sawn timber. So if you look at the lake state and the species, so our selection actually was pretty representative of what we have in the forest in this region, and especially some species here, larger composition here. We see the red oaks, the hard maple, soft maple, basswood, cotton, aspen, and basswood. These are all included in the list of the materials. And so what do we studied in those 2 major aspects in terms of the bonding performance. One is the bonding strengths. We use ASTM standard D905 to characterize that, and then we also study the delamination of the bonding. Okay, and that's the AITC standard. So what this test do, the 905 basically look at 2 things. One is the strength. So it's the bonding strength, under the shear strength under compression. And another aspect is the percentage of wood failure. So the picture here you're seeing here is that, this is a typical, test coupon here. So basically have 2 layers, cross-laminated, and you apply compression, and you just share this bond line here, glue line here, and what you ended up just break it, right? And you look at the surface, after you break the sample, if this is a wood failure, right? It's the so we have 100% here. For example, this one 100% wood failure. That's a good thing. That means that the bond actually is stronger than the wood. That's what we want. If you get a clear shear surface here like this one, so basically it's the glue bond failed before the wood failed. So this is 0% wood failure, right? This is not what we want, because the bond is weaker than the wood. We want the bond stronger than the wood, at least not weaker, right? Or equivalent to, at least. So and because of the cross lamination, if you look at this tested coupon here, so when we apply the load, so one piece is actually loaded parallel to the grain, which is the strong direction of the wood. The other one actually is perpendicular to the strong direction of the wood. And the compression strength is much lower. when perpendicular, when the force applied perpendicular to the to this piece of wood, right? And also the shear strength of this wood also is very, very low. This is commonly we see, you probably heard the term the rolling shear. It's the weak point or weak direction of wood, and so especially for the rolling shear, the properties are almost usually it's a 1/10 of what it's supposed to be. What it is in the strong direction. So my point is that because of that, so the shear strength is not that important in cross lamination compared to parallel lamination. It's a wood failure rate. It's really important. It's the bond is stronger than the wood. The wood fail before the bond fail, right? Or not. Okay, that's my point. So we want to see this kind of failure, right? 100% wood failure rate. The surface covered with all the wood fibers, but not this type. So the delamination basically is the composite, the specimen went into dry and wet cycles, and then we measure, what's the delamination of the glue line, what's the ratio of that. So we have all the possible combinations, 45 types of combinations with all the 9 species we selected, and we studied that. And what we found out, right, when we combine each individual species, for example, aspen just combined with aspen cross-laminated, right? And we found out that there's only 3 species, 3 species actually pass the standard requirement. They're like red oak, basswood, and white ash. In terms of the strengths, especially the wood failure rate. So there is a 75% wood failure rate requirement per the ASTM D2559. Okay, so the other species like aspen or hard maple, they either failed one of the adhesive tab or both adhesive tab. So only red oak, basswood, and white ash, they passed, the wood failure requirement. Okay. And for the delamination test, the AITCT 110. Okay. So this standard require the delamination has to be less than 8%, up to 8% for hardwood species. For softwood species, the number is 5%. So we see that basswood, hard maple, and red maple, these 3 species pass the requirement of the aseptic delamination test. The other species either failed one adhesive or both adhesives. Okay, so when we combine these 2 together, what do we get? The results is that we found that for hardwood species, the basswood actually come out as the champion from the list of the species, and yellow birch was not very didn't perform very well. Okay, and it's basically failed everything, yellow birch. So the other species, red oak, white ash, and red maple, okay, they are doing okay. Okay, and the hard maple and aspen, the primary, they failed the wood failure rate. Okay, that's kind of confirmed with these are the diffuse porous species, hard maple and aspen. The previous study on yellow poplar at West Virginia University, they had a low wood failure rate in their yellow poplar samples as well. So we kind of like confirmed that the diffuse porous samples have to be have a special consideration when we use those species for CLT cross-lamination. So those are the when we combine each individual species. If we actually combine different species together, kind of like the results kind of change dramatically. So see here, we grouped them in the different anatomical features, like diffuse porous, rim porous, diffuse porous, combine them to different anatomic structures together. We see that the wood fader part, when we use melamine based adhesive, they all pass that 75% wood fader rate. There's only 2 combinations with resorcinol, phenolic based adhesive didn't pass, but they're very close. Okay, that's the diffuse porous, and the rim porous and rim porous. And for rim porous and porous, we know that's red oak and white ash. Okay, and this is likely due to the low viscosity and the porosity in the wood, low viscosity of the adhesive and the higher porosity of the wood. Because rim porous, they have larger holes. The adhesive will get sipped into the wood, so there's not much left, in the interface between the 2 pieces. So again, those are the parameters you design for softwood species. We can do improvement, by changing, for example, adhesive application rate, pressure, that kind of thing, to bring this up, more than 75%. It's technically it's feasible. Okay. And if you look at the delamination test, and with the specific each combination, we see that some species that wouldn't pass the test if glued individually. For example, yellow birch wouldn't pass anything. But when we combine it with another species, for example, yellow birch combined with red maple, actually they can pass all this requirement of delamination. So red maple yellow birch combination, so the average, with resorcinol is higher than the melamine based adhesive, but still below 8%. So that, the results from the study is that, when we combine species in cross lamination of of number, it will provide some advantages over the just combine the individual species. So, but when we use diffuse porous hardwoods, we should pay a specific attention to this, because it potentially can cause some issues there. So that's kind of like basically what we learned from this is that we have to not have to the better way to use hardwood species in cross lamination, for example, like cross laminated timber, is like to combine different species together, so that the overall properties of the material, cross laminated material, will be improved. So that's the bonding performance. So another study we did was to make some CLT panels and break them, and to see where the mechanical properties were compared to softwood species or other hardwood species. Right? So since we don't have the mechanical properties directly related to the grading system, so we used a non-destructive evaluation called a E-rating method to rate the panels, the number of boards we used in making the CLT panels. So we randomly choose about 1,000 boards from 7,000 board feet number. They are all 4-quarter sugar maple numbers. So we did a test and get a distribution about the MOE, which is the non-destructive method. Tell us it's a dynamic MOE, very close to the static MOE, which we would use in the calculation or simulation of the panels. And we kind of divided this 1,000 pieces into two groups, based on their MOE. If it's the MOE greater than 2 megapascal, we call it high grade. And if the MOE is less than 2 megapascal, we call it low grade. So it's H and L. So we combine them together, in using the two types of layups. We put a 2 high grade layer in a 3-layer panel, and the other way is to put a 2 layer of low grade in the panel. So and we use the 2 types of adhesives. Now you can see this table here. This M means the manamine, so MHLH, that means it's a manamine adhesive glued with 2 high grade sugar maple, the top and bottom, and with a 1 layer of low grade in the middle layer. That's one tab. We made 3 panels of the first tab, and 3 panels of the second tab, and then 2 panels of the third tab. Use thinner resource adhesives. So, and we did the bending test, and the results. Jumping to this results is that we found that the MOE of the panel can be up to 35% higher than the best grade in the standard PRG 320. Okay, and what even more impressive is the MOR. Okay, it's at least 5 times that of the layup, the highest the layup with highest properties in the standard. And we also compare this to some other panels, 3-layer, for example, Southern Yellow Pine. So we found that the MOR is about 4 times higher than Southern Yellow Pine, and the MOE is about 2 times. Okay, and we'll also compare these results to the yellow poplar panels that made at Virginia Tech. So that's even better. The MOE is 30% higher than yellow poplar, and the MOR is 9 times higher than yellow poplar. Okay, and this sugar maple we're using is the industry grade sugar maple. Okay, so, and another study we did was to combine sugar maple with white spruce. Okay, figure out if we combine softwood and hardwood, make it a hybrid panel, what that's gonna give us. And it turns out that the MOE, we also did 2 types of layup. So with 2 layers of strong wood, the sugar maple, and 1 layer of spruce, the low density, lower mechanic properties. And the other type is the 2 layer of spruce and 1 layer of sugar maple. So these numbers here, SHS, stand for softwood hardwood. S stand for the softwood, which is the spruce, and H means the hardwood, which is the sugar maple here. So we can see that even with 2 layers of spruce in the major force direction. The MOE is still average higher than that, the highest grade in the standard. Okay, and MOR also is higher than the standard. Okay, and the thing is, if we just use spruce, the grade we are using in this study will not get you to the to the E1 grade CLT at all. So you replace at least one layer with sugar maple, that will give you a panel is probably higher than the highest grade in the standard. So that's the point. So and so the other thing we did is the tested the shear property and with this hybrid panel, and we with the 2 layer of spruce in the major direction and 1 layer of sugar maple in the minor direction, cross direction. The modulus of shear is close to the E1 grade in the PS320. But if we have 2 layers, it's obvious it's going to be much higher than the E1 grade in the standard. Okay. And the shear strength, doesn't matter, how the layup was. The shear strength is much higher than the E1 grade. So, with this, the major thing, information from these studies is that, using mixed species is feasible, and probably it should be the way to go when we use hardwood species in cross-lamination, including cross-laminated timber products. And we also confirmed that the superior mechanical properties everybody was talking about, right, when we use hardwood in the CLT. And so the go back to what we discussed about making hardwood CLT and produce hardwood CLT. So making hardwood CLT, my personal opinion, is not a problem. We can make it. In this test we haven't studied the parameters at all. We used all the parameters designed or set for the softwood species, and we still have very good results. Of course, these factors can be studied, right? Can be adjusted when next step when we talk about producing CLT, have a hardwood layer or component in the panels. So so that's I think that's all I have for today. I'd like to have some time to have discussions with the audience. I know I didn't cover everything, but welcome your questions.
Okay, thanks very much, Jinfeng, for that very interesting seminar. And we will have time for questions in just a minute. And but before we get to the questions, I wanted to advertise an upcoming webinar that we're having with MIFB, and on August 19th from 12 noon to 1 p.m. Eastern Time. Daniel Dowden, also from Michigan Tech, will be giving an overview of CLT seismic force resisting systems for mass timber construction. So please join us for that future webinar. And now let's get to some questions from the audience. I have some that have come in here from via the chat, and I will start off with these questions from Dave Newman. Is it likely that a prospective hardwood CLT manufacturer would use two different hardwood species to produce CLT panels. Would they do that because of cost savings from using cheaper species for interior plies or lamella?
Yeah, that's a very good question. Our study shows that, at the technical level, yes, combine different species together, that will improve the properties of the panel. It should be the way to go. But when we talk about, if a specific manufacturer to manufacturing, you know, uh, mixed species hardwood CLT, that a lot of things need to be considered, like economics. Mentioned the cost, right? Because the number price, the resources, they're always changing. What's gonna make the panels actually can make profit, for that manufacturing. That's we have to consider other things. But technically speaking, yes, it's feasible. You can combine red oaks with sugar maple, right? You can make a quality panels, no problem at all.
Okay, thanks, Shinfeng. And a related question then, does it matter the order in which you would place softwoods and hardwoods in the stacking of a CLT product? So like having the softwoods as the exterior plies rather than the interior plies, does order make a difference?
Yes. Yes, it make difference. More difference in the MOR than MOE. That's what our study basically tells us. The changing MOE, for example, you put 2 layers of spruce on the top and bottom layer and 1 layer of sugar maple, versus have 2 layers of sugar maple on the top and bottom layer, and then 1 layer of spruce in the middle. The MOE difference is less than the MOR. We see more increase in MOR when we have 2 layer of strong materials. But this the mechanic properties of the panels can be engineered, can be predicted. They use the modeling. I have some tables in the slides. I forgot to mention, the simulation. So the simulation, worked okay. It's not perfect yet, because we know we have to make a lot of assumptions when we make the modeling, right? But it's working that way we expect it to be. Yes, depends on the layout, that definitely has some effect on the final property of the panel we make.
Okay, thank you. And so question here from Chris Owen. Is there a cooperative effort in hardwood mass timber research? Dan Hindman at Virginia Tech has been researching this for a number of years.
Yeah, it is collaborative efforts, because for the studies we did here, we got support from the industry, especially AGD, forest products, and the forest product laboratory. We are reaching out to other universities in terms of future research. It's ongoing, but we don't have any like fruiting projects yet. I know Dan, he did a lot of research on yellow poplar, and their strategy is a little bit different from us. As I mentioned, they are focused on single species. Yellow poplar is their thing, right? They have a lot of yellow poplar in that region, but for us, we have a more variety of resources in this region. So we, a little bit difference, but they're all hardwoods.
Okay, thanks, Shinfeng. We have another question from Chris Owen here. Does both melamine and resorcinol glues meet PRG 320? This is the standard accepted by the ICC IBC 2021 for mass timber.
Yes. These are the adhesives they use for commercial softwood CLT production. Yes, they meet all the standard requirements.
Okay. And then a question from Dave Newman. Did you measure the weight of the hardwood hybrid and monospecies panels? Curious how much more they weigh than softwood CLT panels, and if the added weight is outweighed by an increase in strength. Can we get thinner panel layups and thinner overall panel thickness from hardwood versus softwood, comparable softwood CLTs, comparable in strength?
Yes, that's a very good question. That's we haven't weighted the the panels, right? But we know that for the sugar maple panels we made, those are 3-inch thick because they are 4/4 number, right? When we combine them together, they're 3-inch thick. And when we talk about softwood CLT, the nominal thickness is 4.5 inches. So even with 3 inches versus 4.5 inches, there's already like savings in the volume of the panels. Plus, way much higher mechanical properties. If we reduce the thickness of each individual layer of the hardwood, potentially, yes, we can reduce the weight, right, and still have comparable mechanical strengths. But the PRG 320 does have a requirement of the minimum thickness of the layers, which is 5/8 inches. So I don't think we can go below that. That's the limit. So I think the thinnest CLT to make is 3 layers of 5/8.
Okay, thank you. And a question here from Brian Craig. The closing of paper mills has reduced demand for plentiful Michigan hardwoods. Do you think that structural uses of hardwoods, such as in CLT, will help drive up their use, especially in the short term?
Yes, I at least that's what I would hope so. So yeah, it the CLT is a value added product. We of course when we talk about at the production of CLT level, we have to consider the resources. The primary market for hardwood still the the traditional industry, flooring, cabinetry, right? That kind of application appearance in furniture, and for the low grade or less utilized species, those are the resources I think we should focus on, right? The species, the wood we used to truck over to paper mill, they potentially can be used for CLT manufacturing. But we are also needed to think about to make the lumber. The sawmills currently probably not designed or geared to saw dimension lumber out of these logs. That's another things we need to study. If the sawmills, how much change they need to make, and to solve the dimension, hardwood dimensions, and what's the cost, and what's the profit, where they are, right? That kind of thing. But yeah, at least I hope more wood can move, shift to the CLT manufacturing to keep the forest industry going. That's important.
Okay, and we received some questions actually before your webinar from a person who was not able to attend, but who will be watching the recorded version, and that's Sarah Connor. So she emailed this morning, and so some of these questions I think you've already addressed during the core of your seminar. However, I'll ask them anyway here quickly. So under what ANSI or APA PRG rules are hardwoods being approved? So it's my understanding that they're not being approved now. Uh, Is that correct?
That's correct. That's correct. So I did talk to others, in the hardwood CLT field, you know, talk about, what's the strategy, what the potential approaches we can actually include hardwood species into the PRG 320 standard. Um, we can start, something very new, like entirely package of data to convince them to put a hardwood, into the standard, which is gonna take much more effort. The other approach is more feasible, is that in the current PRG 320, they allow including layers of, for example, wood composite or engineered wood products, and we potentially actually can, include hardwood species into that, um, just as an insertion, into that. It's existed, it's structure wise, it's already in the standard. It just, added as a layer, something like that.
Okay,
But yes, no, not including the standard.
right. And but you've identified a pathway for moving hardwoods into the standard. And um, a related question, and I think you've already addressed this, are hardwood grading rules being developed for CLT? Is there any effort to do that now?
Very, very good question. I found out recently, the grading system is pretty complicated in the United States. Most of the grading systems or the agencies, they are focused on softwood species. There's one, the NELMA, LELAM, NELAM. I think that's the NELMA. They have a system to grade hardwood number and have a design value associated with the grades, and that's a very good starting point. Of course, we can develop other ways to grading the number, but there is an existing system there we potentially can use.
And would that apply for both CLT as well as hardwood glulam?
I think so.
Okay.
Because it's the design value associated with the grade. That's what we need in terms of to calculate the allowable values for the panels.
And then a final question here as we come to the end of our time. Terry Sherrick asked, are there differences in production efficiencies using various combinations of species?
Can I elaborate on that just a minute, Rich?
We do have to cut off at 1, but yes.
Yeah, okay. I don't mean to elaborate, but Shin-Feng, what I was wondering is, in terms of those who are actually producing these on a scale for use, how much flexibility would there be in terms of mixing species in different ways, and in terms of outside layers, inside layers, and how would that influence the efficiency of putting those things together, as opposed to just grabbing the boards at different species at random and putting them in there? Could you speak to that?
Yeah, Terry, that's a very good question. That's something I'd like to know. Definitely, need a study into that. From the perspective of properties, we always can engineering things. If we grade the number, into grades, we have a mechanical property associated with that. Design values associated with that grade. We can combine things together, no problem. But what it takes for the sawmills to saw this, and where we get it, I imagine this is going to be a a individual separated facility to procure hardwood numbers from different sawmills, and then put them, into CLT production.
Uh-huh. Okay, thanks.
Okay,
Interesting.
thank you again, Shin-Fong. Thank you everyone for attending, and we look forward to seeing you in August. And that brings us to the end of today's webinar. Thank you.
Thank you, everybody, for your time.